Okay, so let's say that you have the compound sodium nitride. What two elements, let me zoom this in here for a second, what two elements do you think are in sodium nitride? Sodium and nitrogen, that's right. So you could tell enough from the name that it's probably going to come from nitrogen. We're going to learn more about naming tomorrow and the next day, but in a nutshell, this is what happens. The anion of a pair, you're going to cut the ending off the end of its name, and you're going to add IDE to it. So that's how nitrogen forms nitride ions. Oxygen probably forms oxides. Sulfur, sulfides. Iodine, iodide. Good. Okay. So we know it comes from Na and N. Okay, those are their element symbols. Now, what we have to do is we have to make sure that this compound balances out to equal 0. And we do that by focusing in on each one of these elements, Na and N. So, let's talk about Na. What group is it in?
First group.
It's in the first group, which means it has how many valence electrons? 1. This entire group would therefore have what charge associated with them? 1 plus, because they all want to lose that electrons. They'd have one more proton than electron. That gives them a 1 plus charge. Nitrogen, on the other hand, that is a group 15 element. How many valence electrons do they have? 5. Which means that if that group forms an ion charge, they'll form a 3 minus charge, right? Okay, so here we go. 1 plus and 3 minus clearly do not equal 0. So what we have to do is be in the mindset of what steps do we need to take to make that happen. And here's how you want to think about it. If N its ion charge is 3 minus, how many sodiums would it take to balance out the 3 minus charge of nitrogen? 3 of them, right? So here's what we do. We're going to take these two and we're going to combine them. We're going to use 3 sodiums because each one has a 1 plus charge, and if we have 3 of them, then you get 3 plus out of that, to every 1 nitrogen. So the ratio is technically 3 to 1. Now, once you put the two of those together, you no longer need the ion charges that you see up here. We don't have to bring them down here because we know what they are. Once you have 3 NAs, you have 3 plus. Once you have 1 nitrogen ion, you have 3 minus. Those balance out to 0, so they cancel out. You don't have to write them anymore. Now, this number down here is called a subscript. And in formulas, it represents the number of whatever symbol it is that comes in front of it, how many of those that you have there. So in the case of this compound here made of sodium and nitrogen, the overall ionic compound formula is Na3N. Yes. Let's go to page 224 for a second. And we have 5 problems there that we can take a look at and work with to get the hang of it. 224. Okay, first example, number 19, they give us potassium and iodide. Okay? And you guys just told me iodide a minute ago, so it must come from the element iodine. Now, with this one here, potassium, if we look at the ion charge that it forms, again, you're going to need a periodic table to do this because you got to relate its charge with what group it's in. What charge would potassium have? 1 plus. And iodine is a group 17 element, so its charge would be 1 minus. Do those ion charges balance out to 0? Yes. So in this case here, when we combine the two, those 2 ion charges cancel out. The formula for potassium iodide then is Ki. 20. The 2 elements they want you to put together are magnesium and chlorine. So let's talk about magnesium first. It is a group what? Group 2, which means what kind of charge does it have? 2 plus. All group 2 elements form a 2+ charge when they try to ditch the 2 outer valence electrons they have. Chlorine is a group 17 element, and they all form 1- charges. Good. All right, so now we're in the scenario where we have a 2+ and a 1- charge. Okay? Who do we need 2 of to make this balance to 0? Yes, good. Magnesium and then chloride. I need 2 in order to balance it out to 0. So the formula is MgCl2. All right, let me show you one special thing that happens when these ion charges are not so easy to work with. Let's say that I have element X and I have element Y. X is a 3+ charge and Y is a 2- charge. Okay? Clearly, those two do not balance to 0. Okay? What is 3+ plus -2? -1. It's 1. It's not 0. So what that means is we have to figure out how to do this. Now, we can do it one way, which is mentally. Okay? Think back to that idea in math class called the least common multiple. What is the least common multiple of 3 and 2? 6. So let's say I did this. What if I put a 2 down here, and I multiplied the 2 of those, and I put a 3 down here and multiplied the 2 of those? What's 3 times 2? 6. And what's -2 times 3? -6. So in this case here, by putting a 2 there and a 3 there using the least common multiple, I can make it equal to 0. So it would be x2, y3. All right? Now, let's say you're not too great with math and you need an easier way. Okay? And I'm going to flip it around. Let's say I have an x with a 2+ charge and a y with a 3- charge. Okay? There's a sneaky little way of doing balancing these compounds where you don't have to do any math, and here it is. It's called the crisscross. You're going to take these ion charges and you're going to do this. You're going to crisscross them like that, and you're going to go from superscripts to subscripts. So the x would now be followed by a 3, and the y would be followed by a 2. We always keep the subscripts positive. There's never a negative subscript. That's how you deal with difficult charges. If you can't figure out how to balance them to 0, crisscross them, and they'll balance out to 0 every time.